Sup, Milks.
It's popping, nephew.
Boot camp vocabulary.
He to be to Monaco.
Yep. And he's Milks.
And Gunnar, still with us.
Yeah.
Might speak this video.
Maybe.
Watch
If
out.
you know so many vocab words, you chime in. It pops up on the screen there. So,
Video 2,
video 2, lecture
Vocab.
2, vocab.
like every unit will be this.
Every unit's going to have 20 words and the same definitions
Can you
and
see
all
me
that
now?
business. Know these words. Study
Right.
until you can't get them wrong because you're going to have to match them and beat 85% or something
That's
on
what I'm
that
saying.
quiz.
80, yeah. 80. So first one, meter.
It is a unit of measurement.
Oh, wait.
You forgot the learning target. We're going to hit this up. Every time a learning target is focused on, you're going to see it bounce across the screen.
And there it is. So we're going to be able to
Define
these
specialized vocabulary. Boom.
see it.
A meter. Fundamental unit of length in the metric system. It's about this long. It means 100 centimeters.
Yeah, I just
A
actually,
boom.
there you go. I just actually lent out a bunch of meter sticks. So now I don't have one to show you, but whatever.
Let's keep it rolling,
And
bro.
rhyming with meter is liter, and that is a fundamental unit of volume. Unit of volume, about 1,000 milliliters.
It's about a half a liter.
Yeah, about half a liter.
Gram. Fundamental unit of mass in the metric system. A gram is a 1. It is the 1. A kilogram would be 1,000 grams.
Correct.
1 gram is the base unit of
And
mass.
when he says base unit, is all three of those said fundamental. They start with fundamental, and that's
Yep.
what he's getting at. That's the base. Yep, the fundamental. Okay. Mass is just the amount of matter in the object. How much stuff would be there?
atoms and stuff.
Yeah.
How much is packed in there?
How much
Makes
is
it-
there?
More packed in gets heavier. Less packed in
True.
gets lighter.
True.
That's what we know. Is
Right. Volume. How much? Oh, is this your turn?
It don't matter. It's the amount of space that matter takes up. We said matter was how much stuff is packed in there, and volume is how much space it takes up.
True.
Bingo.
And then if I relate the two, I get the density. This is how much matter per volume or divided by volume.
Mhm. Anytime you see a slash in an equation like that, it translates verbally to per and means divided by.
Yeah, miles per hour.
And the cool thing about density is if you take the mass of an object and divide it by its volume, you get a relative constant to that type of matter.
Ooh, it works like a signature.
It is. So like all gold, if it's pure, has the same density. All steel roughly has a similar density. Okay. It's a very important tool, like Milk said, fingerprint for identification of
Can
materials.
be used. Can be used. All right, big bad word. Precision is how we say that.
Mhm.
And this is how repeatable the measurement is. Do I get the same number every time?
If you're hopping on and off the bathroom scale and it tells you a different number every single time,
It's not precise.
it's not. But at the doctor's scale, you hop on that, it's going to tell you that you're the same weight every single time because that's a special scale that is designed to be precise.
correct.
Accurate. My turn?
Well, kind of still.
Okay, well, accuracy is how close your measurements are to an accepted value. Like if you stand on the scale at home and it says, Monaco, you're 200 pounds. Then I go to the doctor's scale and it says, Monaco, you're 200 pounds. These two scales are pretty accurate because the doctor's scale, which we trust more, is agreeing with my home scale.
Right.
How close your measurement, my house scale, is to the accepted value, the doctor's
Yeah,
scale.
what he's saying is if he's really 200 pounds, the scale should say 200 pounds. If he's really 200 pounds and you get on the scale it says 190, we like that scale. It's not so accurate.
Not so accurate.
Right?
Yes.
That's
Well
what
done.
we're
Sir.
getting at.
Well done.
So, matter.
Mhm.
What's the matter for you? This is the stuff that all things are made up of that occupy the volume. And we will get into like the elements, the atoms.
Yeah, I mean, everything's made of atoms. So when we say stuff, we're pretty much talking about atoms, compounds, mixtures, and elements, which are our next vocabulary
Right?
terms.
And guess what? It's even in the air right here. You can't even
Yeah.
see it, but we're
They're
breathing
there.
it in. You go ahead, breathe. See?
My students
Matter
knew this
stuff.
yesterday when we were talking about it. So an
Okay.
element is a unique kind of matter. It can't be broken down by any chemical changes. It can't be changed. It's as simple as it can already be.
Right.
And there are, 118 pure elements and
Right.
on what you know as the periodic table.
So the key here, though, that differentiates this word element is there's multiple atoms in that sample we're talking about. They are just all the same thing.
Yes.
They're not different by any means. Their neighbor and each other are all the exact same pieces. Element.
And we think
Multiple
of them
atoms.
as particles. I'm honestly thinking in my head,
little
like
spheres.
you go to the store. What if there was like bulk red Skittles? They'd all be the same.
Right.
You'd look at the whole bulk jar and say, that's an element of red Skittles. Each one is an atom of red Skittles, but they're
Right.
all the same.
Right.
And that's kind of what we're saying.
Right. Now, a compound's something different. That's
Yes.
when I take more than one atom, two different kinds, so this kind and this kind,
Yep.
put them together, and now they make a compound.
They're stuck together. It's like smashing a red and a green Skittle together, and now
Right.
it's a different thing
But then I can, by chemically doing something to it, break them back apart.
because
Which
you
I
had to
can't
do
do
something
in an
chemically to get them together in the first place. So
right.
compounds are reversible sometimes. So most times.
Yeah, most times. Right.
Anyways, mixtures
That's
more
right.
complex. It's when you get a bunch of different substances like compounds or elements, maybe both, and mix them all together and they're not chemically linked. They can be separated by physical means. It's coming up on Halloween time.
Ooh, yeah.
Your candy bag is a mixture.
That's
you might get certain packets in there that are pure.
And I bet you're going to hang out with your brother or sister and physically separate them and trade the ones you like and ones you don't like. You're going to
Totally.
physically separate them.
Some of those individual pieces of candy might be more like an element, like a sour, the lemon head.
Sure, like
Always
a
the
Hershey's
same.
bar is just all chocolate straight
Right.
through.
Others might be compounds, more like,
Butterfinger.
Butterfinger. There's more than one thing inside the package. But
Yeah.
if you look at the whole sack of candy,
It's a mixture
it's totally a mixture.
because you can separate them.
There's different types of mixtures when you talk about chemistry, though.
Right. So
There's-
first one.
Heterogeneous mixture, which is a mixture that is not visually the same throughout.
Hetero means different.
Yes, and it would settle or stand if it like was let to sit. So like mud water,
Right.
the mud would fall to the bottom, the water would
Uh-huh.
sink to the top, float to the top. It would separate.
Yes.
Um,
all by itself.
Your bag of candy at Halloween is a heterogeneous mixture. You can see that there's a lot of different stuff in that bag.
If it doesn't look like one thing, if it looks like more than one thing, it's heterogeneous. That's
Right.
really the way we do it. So the homogeneous is the opposite. Homo means same. That's why I was almost sneaking out there. Homo means same. So now it looks the same throughout, and so we can't tell the difference. So it won't settle upon sitting, sugar water, or in what we know is Kool-Aid. Once you make it and the sugar dissolves, you set your glass of Kool-Aid out. Does the sugar ever fall to the bottom?
No sound.
Not once it's dissolved. It's formed a homogeneous mixture. Looks the same throughout.
Now, pure substances, we're going to say pure a lot this year. We're going to say substance a lot this year. It could be either an element or a compound, but what it is, it's all the same throughout. Okay?
Yes.
It is not a mixture. So we're talking about pure salt, pure sand. Nothing else
No contamination.
mixed in there, no contamination.
Can't be two things. Can't be water and salt. It's got to be just salt or just water.
Right. Although that term can be, oh man, this air is so pure, but air itself is a mixture.
Of stuff.
It's a term that's tossed around a lot, but in chemistry, it specifically talks about matter composed of one element
or one compound.
not a mixture.
So everything there in that box is the same.
Right.
And then speaking of the box, is this particle diagram where just like the box in the bottom corner that is me and Monaco and Yanar, and you can see us, in that box would be spheres for a particle.
Right.
And if it was all the same, it would be pure. And if they were different, it would be a mixture.
Period. End of story, right?
Good.
You got any more words?
Whoa. That's it.
Whoa, that is all, folks, with, minute and a half to spare.
See, you're doing good. So now you need to figure out a way to study these words.
Mhm.
They're going to show up exactly the way they are on your quiz. There's 20 of them.
Yep.
You got to get 16 right. If you need more than one try, fine. If you need 6 tries, what are you going to do next unit
Yeah.
so you don't need to do it 6 times? You see what I'm saying? Like,
Right.
can we cut that down to 3 or
Because
2?
I swear to you, studying works.
Yes. And now we get the opportunity in this class, the way we do it, for you to figure out what works best for you study, because what works for you might not work for me and him, might not work for somebody else sitting at your table. And that's the real challenge to this. What is actually going to work for you?
Yeah.
And if you're frustrated and you're not figuring it out, come see one of us, maybe more in private, right?
So maybe check this video out a couple more times. Make sure you
Sure.
wrote your definitions correctly.
Flashcards.
Listen to us and how we define them. Maybe something will click in your head if you're an auditory learner.
Right.
If you're a written learner, you'll get that out of it. Maybe make some flashcards, do your thing, find a friend, text definitions and words back and forth. See how
Sure.
it goes. I'm only talking because we got the time.
Yeah. Oh, wait. Time's running out, though.
See y'all later.
Yeah.
Gotta figure out how to stop this now.
You'll find out.